Thanks, Alan, and welcome, everyone. My name is Gladys Rama. I'm the editorial director, and I'm so pleased to be welcoming you to today's summit called Cloud Native 101 for Enterprises, and brought to you by Nutanix. The editorial staff here at redmondmag.com, Virtualization and Cloud Review, and AWSinsider.net have worked really hard to bring together some of the best independent experts on this topic, so we really hope that you enjoy it. Before we start, I do have a couple of quick announcements. First, of course, this event is being recorded, and you'll be able to watch it for future viewing. You'll get an email from us when the replay is available, generally within the next couple of days. Second, each of today's 3 sessions will be followed by a 5 to 10 minute Q&A, so please be sure to put your questions into the Q&A area of your console there as they come up so we can get them answered for you. Third, during today's 3rd session, we are giving away an electric hybrid bike, but you have to be present to win, so please be sure to stay on for the entire event. And finally, we have resources for you from our sponsor, Nutanix. They're available right now on the console. So do check those out, download them, ask questions of the Nutanix folks when their presentation comes up later. It's because of Nutanix underwriting this content that we can bring you this summit. So we really thank them for sponsoring this event, sponsoring and supporting the community. And we ask that you check out those resources so we can bring you more events like this in the future. Now on to the first session of today's summit. This one's called Cloud Native 101, Understanding Cloud Native Basics for Enterprises. And it features Greg Schultz, the founder and IT analyst at Server Storage IO. Greg is a Microsoft MVP Cloud Data Center Management and previous 10-time VMware vExpert, and also a frequent presenter here at our summit. So you're probably familiar with his presentations. In case you didn't know, Greg has worked as a customer in various IT orgs in different roles, as well as a vendor, consulting analyst, and the author of several books, including Software-Defined Data Infrastructure Essentials from CRC Press. Greg brings a diverse background with real-world perspective across applications, data infrastructures, hardware, software, and clouds. Greg, welcome to have you. We're so happy to have you today. The floor is yours.
Thanks, Gladys. Hello, everybody, and welcome to today's Cloud Native 101, Understanding Cloud Native Basics for the Enterprise. This is Greg Schultz, and we are going to spend about the next 45 minutes or so going through some material on Cloud Native, and as well as addressing your questions and answers. So with that, let's just get right into it. So, understanding the Cloud Native basics, what we're going to cover. Just real quickly here, if the answer is cloud native, what are some of the essential questions that enterprise environments need to ask? And we're going to look at those among others. And some common questions include, what is it from a technology collection versus an architecture perspective versus DevOps? What are the benefits and enablers of having a cloud native environment? And is cloud native a developer, operations, systems, or infrastructure-focused topic? And what we're going to learn and talk about today is cloud native as a transformation enabler, cloud native technology, the tool, the architectures, cloud native and DevOps, some of which we'll hear more about in the following sessions during today's summit. So let's get into this a little bit deeper. Sometimes I'm going to say cloud native, sometimes I might say CN. It's just one of those acronyms out there. We like to have acronyms. So setting the stage. How much and what is your organization doing with clouds today? Are you under any mandates to do something cloud native related? In other words, are you under a cloud first, cloud native mandate, or somebody heard about it and they say, hey, we should be doing this? Or are you just exploring and getting your feet on the ground? Well, what's your focus? Is it the infrastructure? Is it the platform? Is it the higher level software, app development, or something else? What are your financial cost and time considerations? Are you looking for some magic pixie dust, something that you can wave that magic wand and everything is resolved for your organization? Is yours a new greenfield, no existing apps, or is it a brownfield or a hybrid environment where you've got legacy apps, you've got some new things coming, and do you have particular cloud native applications in mind, or maybe coming out of today's session, you'll have some ideas on where to get started. All right, so as I mentioned before, cloud native. What is your cloud native focus area and interest? And what I mean by that area of interest is, are you an app developer? Are you infrastructure? Are you operations? Are you an architect? Are you a consultant? What's your focus area? What's your area of expertise or domain of focus? And when I say domain, I mean area of knowledge, expertise, of interest, as opposed to a domain name. All right, so on this chart here, look at across it horizontally at the top. That could be the focus of the business, an architect, an app developer focus. Down below, we have that horizontal, which could be more of an IT, data infrastructure, admin, ops, engineer, something else. But if we cut right between both of those, is cloud native. What is it? Well, there's a different focus that can be going upstairs across that business architect, app developer, or going downstairs across the infrastructure. What is needed, how to do it, where to learn more, which we'll work our way through this, okay? And there's the hybrid that cuts right through the middle of all those horizontally, which is this notion of DevOps, which combines or overlaps with that upper layer of the app developer with that lower level, that infrastructure. Everything is not the same. Depending on the size, the focus of your organization, you may have clear-cut separation between the business, the architects, the app developers, the lower-level infrastructure, and maybe a DevOps team or focus somewhere in between, or they might be more converged. Everything is not the same. There's going to be different approaches. So just because you see one way doesn't mean you have to do it one versus the other. That's one of the neat things about the cloud native approach, that as we go into it more, it's have it your way. It's part of this whole notion around a hybrid IT, have it your way, have the practices, the technologies adapt to your environment, what you need to do. So there's a bunch of little bullet points across the bottom here. What is it and what is it not, which we'll dig into more, the culture, the tools, some of the different barriers. But a key one is whatever it is that you are going to do, you want to build for success. You want to learn the new technologies, the new tools, the new techniques, and how it can be an enabler for the organization. So let's move on from here, and just a really big picture is this is what it's all about. Is that, if we were to abstract everything underneath, it's what's up on the top there. Different applications, different kinds of applications, supporting the business, supporting the customers, the clients. Down below that in that dotted area, that's that infrastructure, the data infrastructure that supports the apps, that supports the deployment, the production, that brings in all the different tools, the technologies, cutting across edge, on-prem, core, hybrid cloud, regular cloud, as well as different layers up and down. We see over there on that right, going from higher level to business app focus to the lower altitude, lower layers in that stack. So we're looking at things in a very multidimensional view here, from that upper piece to that lower point and different points in between. Another way of looking at this is, again, this big picture. It's the apps and the data infrastructure. And the data infrastructure is what's there to support the apps, their development, the production, the delivery. But we've also got these different notions that fit into the equation of lower-level infrastructure as a service, or infrastructure as code, if you like, platform as a service, software as a service. And part of this notion is that, again, hybrid. You can tie different pieces together. You can use different things in different ways to meet your needs and requirements. In other words, these different tools, these different topics, they play to your organization. How will you craft them? How will you compose them? How will you define them to meet your particular needs? So let's go into this a little bit more. If the answer is cloud native, what are the questions? All right, let's start to go through some of these questions a little bit more, which is going to include what's it all about? What are the benefits of cloud native? is cloud native for everybody, everything, everywhere? Well, of course, some of the vendors are going to jump up and down and say, well, of course. And some of the naysayers are going to say, well, we're going to find a balance there for you. We're also going to touch on what cloud native is not, at least today. What are some of the architectures? What are some of the technologies and tools? Where to start and how to build that success that we mentioned a little bit ago. And then, as a reminder, this is being recorded, so towards the end there, I've got some resources for you to dig in a little bit more. All right, so what's it all about? It's a new approach for IT development, i.e. software, and deployment of the business apps, as well as enabling continuous integration, CI, with continuous delivery. In other words, delivering pieces of an app faster, getting them out there quicker, being able to deploy quicker, back off of changes quicker. It's just a way of doing things that enables a streamlined application deployment as well as development and production scaling with stability. In other words, increasing that speed and velocity for application development enhancements while abstracting that underlying data infrastructure, the resources, and enabling portability, whether you're running cloud native on-prem to a public cloud, a hybrid out to the edge. And that's one of the key tenets, is that cloud native is not tied to one particular cloud, one particular platform. That's one of the ideas, is that you've got that platform, you've got that agility to move your app or its deployment to different points, to different places, to different platforms to meet your particular needs. All right, so what is cloud native all about? Just building on that. It's a collaborative development, architecture, and techniques, as well as the technologies and tools. As I touched on a little bit ago, it also combines across a couple of different things here. It combines across that upper layer, the development, the software, the apps, with a new culture, new techniques, processes, as well as architecture paradigms. About that continuous integration delivery, faster releases, fixes, enabling new biz functionality to be able to roll out quicker without having to wait for a bigger chunk of the application or services to be deployed with it. It's also about the data infrastructure, some new tools, technologies for enabling that development environment as well as production that leverages containers, orchestration, cloud-like resources, services, and management. That's that key around cloud. It's around the management, that abstraction. So we've got going horizontally here, the evolution, the initial development down there in that lower left, the initial development, whether it's build, buy, making a change, porting it to a different platform or refactoring or re-architecting or lift and shift. And that could go, this evolution goes from mainframe to mid-range to client server, PC web, platform software as a service. But we see these different evolution approaches, porting, lift and shift, going from physical machine to virtual machine, maybe just lift and shift from a virtual machine running something that's fairly well contained into a container. And what we're seeing now as we go more over to that lower right is another step, which is more than just that lift and shift, that rehosting. It's recomposing that application or building something new in a new way. And with that, let's dig a little deeper. So what it's all about, again, agility, flexibility, scalability, resiliency, speed of development, and speed of deployment. And part of that is, yes, we can get things out there quicker. You get the code developed quicker, get the fix developed quicker, get it deployed. But it also means, as we saw just the other day, that ability to back something out, to fall off of a change, get back to the previous version, and reduce the amount of impact or downtime. So it's about how quickly can you get something out, but it's also about how quickly can you get back to where you were, to a previous known state, then go back, fix the code, and then push it out there as you have that capability. So some might say, well, deja vu, well, geez, we've had that in the past with different platforms, different architectures, and yeah. On the other hand, this might be new and revolutionary. So again, our focus today is around this cloud native approach, which is, again, that transformation of how apps get developed, deployed, as well as how operations and support, how they come together. They also allow that agility with that continuous integrate and delivery to enable a rapid cadence of getting fixes, getting new enhancements out and deployed quickly. But there are also opportunities for cost savings on both development time as well as on hardware, software resources by being able to right-size what resources you're using, to burst when need be, but to also pull back on the amount of resources when not needed. There's also that ability to scale up, scale out, and scale down, which ties into adapting to what's the amount of resources you need at a particular point in time. Some other things is less time that the app environment, the developers, need to spend configuring and caring for their data infrastructure, more time for them to focus on the biz app logic, enabling faster upgrades, remediation, again, that portability that we touched on. So, as we continue, what are the benefits? What are the benefits of a cloud-native environment? Well, those benefits include for the business. For the business, it's that agility, address changing market, changing customer, different needs, requirements, opportunities, to get something out very, very quickly rather than having to wait until the next point release or something else occurs. There is that potential cost savings, being able to streamline on how apps can be developed faster, which might mean staffing, but it might also mean being able to leverage your staff more efficiently, but also more effectively. And then, as I mentioned a bit ago, too, there is that opportunity to either save or get more value out of your hardware, software, and cloud spend. That flexibility to rapidly scale up to meet surge demands, but also scale back down when not needed. So it also helps that transformation, evolving IT from a cost overhead to a business and transformation enabler. All right, so all good things for the business. For the development side, again, it's that streamlining the app development and deployment, faster, smaller releases, focus more on the biz app logic and function versus underlying platform engineering. In other words, improve on the app resilience and supportability without spending a lot of time reinventing the wheel or coming up with a lot of custom fixes that can be provided by the underlying data infrastructures. For the infrastructure and ops, it's that improved situational awareness, having more insight, observability, telemetry into what's happening, and enabling that management, as well as enhanced resiliency, flexibility, being able to deploy the apps where needed to leverage the different resource types for the best service delivery. Okay, all good things. Well, we've got to bring in a little bit of levity here. What cloud is not? Cloud native can be many things. However, some things it is not, at least today or yet. We're getting there. Cloud native is not a cloud per se. Cloud native can run on a public cloud, Azure, AWS, take your pick. But it can also run on-prem. Cloud native can run on hypervisors. You could run the containers on a hypervisor, on bare metal, a lot of different options. You can run them on a hyper-converged infrastructure, a lot of different options. That's part of that flexibility. Cloud native is not magic pixie dust to instantly, emphasis there, instantly solve all biz or IT issues, that there's a bit of an evolutionary part to it. Once you get further in to your journey on cloud native, you will then be able to start to realize that you can get apps out quicker. You can get a new functionality out quicker. But that magic pixie dust comes over time. Cloud native, at least initially, is not for all apps, but for many. And we'll touch more on some examples there in a few moments. So again, what we're doing here is just level setting. There's a lot of different capabilities. There's a lot of different things. And one of the things is that cloud native is not just a DevOps buzz topic. It's not just a container topic. It's not just an app developer topic. It's all the above. It embraces all these different things. So what are some cloud native caveats? Well, we just touched on some of those. And what it really comes down to, it depends, like a lot of different things. What is your environment? What are you looking to do? Where are you looking to go? What are your current skill sets? What do you need to ramp up on? The goal is success for the business to embolden and gain support for something more, to do something else. So, for example, explore how an existing app can be transformed in steps, phases, or over time. Or do you got an application that's got a really high degree of technical difficulty? Is it feasible to do as your first project? What are the internal, external resources needed? As opposed to maybe there is something that is a lower priority that keeps getting ignored or deferred that might be a good candidate for that initial cloud native project. Again, the goal is to build success for the business. So the business says, yeah, we want to become your big cheerleaders. And that also means we'll help fund things if you can get them to us quicker and in a more cost-effective way. But it's also about gaining that confidence, that knowledge, that expertise that you're able to deliver and having those cross-functional teams as well as to be able to support things. Okay, so what this does, let's put it in perspective. Let's have a visual here. And with this visual, it's showing us on the left the traditional, the classic approach. In other words, the business says, hey, developers, we need this done, or hey, we just went and bought this, take care of it. Developers work on it, they do the quality control, they hand it over, it gets put into production, the users get to see it, there's problems, the support staff tosses things back to the developers, maybe the developers toss something back to there's a lot of back and forth, over the walls, through the walls. Or maybe users going back to the business saying, hey, this isn't what we really wanted. There's a lot of back and forth, a lot of time spent in an environment like that. You could call this a monolithic, you could call it a waterfall. There's a lot of different names and acronyms that this applies to. But what this goes to is, over there on that right, is an evolution. If you prefer revolution, go for it. But it's an evolution of a variation of what we've got over there on that left, which is a continuum loop. In other words, the business says, here, we need this, development does it, they push it out, they get it ready, it gets pushed out in production, the users see it, hey, we need an enhancement, development works on it, the quality control, the support, maybe site reliability engineers, they're all involved so that now these fixes, these enhancements can happen on a continuous basis, whether it's that integration, that delivery, that improvement, the fixes. So the whole idea is around streamlining, breaking down barriers where people and the different teams are collaborating and working together. That's part of that culture change. Okay, so what are cloud native architectures? So the cloud native architectures evolve and span from how the code is developed, how it's tested, and how it's deployed to production in containers. So this ties back to it. Well, does this mean this is all about containers and Kubernetes? Those are parts of it. Is this all about just how we do a new way of development? Is this a shift from Agile, Scrum, whatever your process happens to be? This is encompassing. It's about streamlining and removing barriers so that you can scale and that whatever it is that's being developed, deployed, can be monitored, managed, and have that resiliency. And putting more of that resiliency into the infrastructure, the data infrastructure, but also allowing the apps to be able to tap into that and have their self-resiliency such that they can scale up, they can scale out, that they've got that resiliency such that they can restart, they can do different things and recover with some of that information, some of that built into the architecture, leveraging the capabilities that are underneath. And it also means going to an event-driven architecture that supports being able to meet different needs. The apps are decomposed into smaller independent entities, microservices, self-contained entities, maybe in or on containers or multiple containers or pods, but with well-defined interfaces, application program interfaces or APIs, and behaviors They also leverage backing services for security, analytics, monitoring, notification, storage, streaming, database, distributed caching, message brokers, among many others. Let's look a little closer here. So as we look at this here chart, this is a classic monolithic. Now, let me put a caveat here. The monolithic could be one big giant application, one big giant executable, maybe a bunch of DLLs or libraries. It could be multiple pieces of software, depending on what your environment is. So this could be a single application, or it could be representing a subset of an application that spans across many different systems. Okay, but what we're looking at here is that in this particular example, the big dotted lines in the middle there, from about the middle of the screen there, okay, that represents the collection for a particular application, which might be ordering for an online store, okay, where you've got there on the left your user interfaces, different things, and over on the far right, your management, your orchestration, different things from the data infrastructure. There in the middle is that within that app, whether it be a single EXE or multiple EXEs, but that delivery package, that there's different modules, different functions of identity and rights management, product catalog, ordering basket, inventory, marketing. These all may be separate pieces, or they might be compiled into one big delivery executable, depending on what it is that you're deploying. Okay, so we'll get that in mind, that the other thing is that there is messaging that's capable of going across those different routines, that this might be running on one server, it might be running on multiple servers in a cluster, and that it might be on one or more databases. Now, what we want to look at here is, let's go forward a bit, which is looking more at that architecture. So over on that lower right, we're going to get to that in just a moment. That sets the stage, a preview for where we're going. But in this particular, it's looking at, from on the left, how the code is run, debugged in that development environment. Being able to give that developer a miniature version of the entire environment, including something similar to what the production environment looks like, and to be able to do that on a laptop. Being able to have those app and code repositories, nothing new there per se, but where the developer can check out the code, make the change, post it back in there, goes into that build, integrate, test environment. Okay, deja vu, might look familiar. Where the environment is configured and then it's pushed for deployment, that is then pushed down into the environment. So you might say, well, geez, that looks similar to what we're doing already. Where's all the magic happening? Well, part of it is what's there in that lower right, but part of it also goes back to what we saw a couple slides ago, getting down, removing those walls where things are thrown over and passed back and forth, where there's more integration going amongst the different teams, the different developers that are focused on different pieces of what needs to be done. So let's look at this a little closer. This looks similar to what we saw a few moments ago. And in other words, if I click back, okay, here's the big monolithic, right? There in the big dotted lines in the middle, the big monolith, the big app. Well, let's come back over to here now. What's happened? Okay, what's happened is this, is we've compartmentalized, we have decomposed the different pieces of that application into their own individual entities. We've got that formal API gateway out in front that the user, the presentation, the interactions, whether it be mobile devices or browsers or IoT digital twins, are connecting through those well-defined interfaces, that API gateway, that in turn connects to the identity and rights management microservice. There's the key word there, microservice. That microservice is self-contained, that the other parts of the application could be on or off. That could still be running. Granted, it may not be able to do a whole lot, but that it's not reliant on that one big executable or that one big system or collection of applications, that it's self-contained. So we've got one for product catalog, ordering basket, inventory, that loyalty program. So, well, if all of a sudden, if this is, say, a website, and all of a sudden there's a lot of people that are logging on and they're starting to shop, well, those microservices, the code, the logic, their own individual repositories, those are being deployed on containers in a pod. And if all of a sudden there's a surge in demand, well, spin up more nodes to support that particular part of the application. As people log on rapidly and their rights are identified, spin up the product catalog, spin up the ordering basket, the fulfillment. All those can be scaled up but also scaled back down as things evolve. Again, this goes back to that event-driven. So that might say, well, yeah, but I'm still not seeing how that differs from that one big, giant, classic monolithic. Well, the one piece is that, let's say there's a change that only impacts the ordering basket and billing. Only that microservice needs to be changed. The other parts, the identity, the catalog, fulfillment, the loyalty programs, those can be untouched. Likewise, if only the loyalty program is being updated, that's where the new app gets pushed out. Everything else is the same. So that's part of that modularity. But then the scaling. And then being able to tie into that, we're seeing that rather than going to one big giant database, which you still could, each application, each microservice is now self-contained. That it has that ability to operate independently of the others, but also to be able to work with them and orchestrate across that. And again, over there on that right, we see the management, the orchestration, provisioning. So as we build out on this, okay, here's where things hopefully start to come into perspective a bit, which is we see up there in the top center that application environment, that continuous delivery, and something is going to get pushed out. Well, what we're seeing here is on that lower left is the declarative nature, that software-defined infrastructure of defining for a given pod what type of nodes are needed, how many are there, what's the resiliency, how does it scale, things like that. And for example, there's a pod there with multiple containers that might be handling identity management. There could be another pod handling the ordering catalog, or another one handling customer loyalty. So each of those different microservices, identity, product catalog, ordering, fulfillment, marketing, loyalty, each of those could be running in a pod with one or more containers on one or more nodes. This comes back. This is where that magic starts to happen from the infrastructure side, being able to scale up that application as need be. The magic on the development side is how that code is developed, written, deployed to be able to leverage those underlying services and to be able to scale as we keep working our way through this. So this is where across that bottom, that's where containers and container management with, for example, Kubernetes clusters comes in, which could be deployed out on a physical machine, a virtual machine, a cloud, is that if you think about it from about the middle on up, that's all portable. Where are you going to run it? These don't have to run on one cluster. They can be in different locations across different pieces. All right, so what are some of the technologies? We've talked about this, and let's just look here real quickly at a few more. There are the developer tools, which could be low-code, visual object-oriented, WebASM, WebAssembly, legacy and emerging code tools. For example, you could still be working in C#, C++, Java, JavaScript, HTML, whatever your preference is. And leveraging various runtimes, operating systems, libraries, internal and external, as well as Docker Desktop, Minikube, Visual Studios, along with a lot of other different resources. For the backing services, again, we touched on these, your databases, your repositories, your caching, your registries, monitoring, API gateways. And from the container, there's the clusters and management orchestrations that can be running in different places. All right. How to decide what to do, where to start, how to build for success. Okay, start small and simple. Go for low-hanging fruit, so to speak, that have low technical difficulty. Look at apps or business functions that they may not be marquee, yet would provide business or customer benefit very, very quickly. In other words, this is part of that working towards success, building up that success, getting the business behind you, wanting to do more. Okay, if they want you to do more, then say, great, open the checkbook. Apps that can benefit IT as well. In other words, addressing classic shoemaker children syndrome. IT is developing for everybody else. Well, maybe there's some things within IT that need to be done that keep getting ignored. The whole idea here is prioritize and address apps and workloads with cloud native that are tech feasible, that could be strategic or tactical, but could also just be something that needs to be done, something that keeps getting pushed aside. It could be greenfield, it could be brownfield. It could be done in a lot of different ways. And then it's also to decide, are you going to buy, subscribe, or outsource? If you're going to have somebody else build it for you, who's going to maintain the cloud native after somebody has written it? And then you got to go in there and assume and inherit their tech debt. Okay? Are you going to do it yourself and build it? What's the experience and what's needed for training and timeline to do that pilot study, that pilot proof of concept? All right, so some considerations. We've touched on these, but let's elaborate on them real quickly as we start to go into the home run here. It's balancing the business needs with technical architecture, experiences, tools, and techniques. Avoid the moonshots. Yeah, it'd be fun to do this big, giant app, all cloud native, looks good on your resume or your CV. You know what, go for quick, easy projects, build that success, that experience, that confidence, so you get on to the next one and just keep going and going and going. It's that architect and design and build as though you will be the one supporting that app in production. Integrate the telemetry and diagnostics up front versus trying to modify afterwards. Look for how low-profile projects are being overlooked. This could be a really easy one to get into. There might be too much risk. Yeah, it'd be great to do the marquee project, whatever that happens to be for an organization. Now, do something that people are going to look at and say, how did you get that done so quick? We want to learn. We want to watch. Can we work with you? Can we put somebody on part of your team? We really like what you're doing. Watch out for that complexity creep. Start simple to start out with. Build that confidence, that comfort, that success. In the race to eliminate old tech debt, watch out for creating new future tech debt. In other words, watch out for what you get locked into, and in that race to get something done, are you just kicking the can down the road with a new approach? It's all about the business versus the tech building blocks and the architectures. Yeah, those are all part of it, the building blocks, the tech, the tools, etc. But it's really about enabling the business, because if you can enable the business, then you justify keeping yourself, what you're doing, around. Okay, and then if you've got the interface with other apps and software as a service on platforms, how's that going to be done? How are you going to go about doing that? And again, get that disciplined, agile environment culture that is flexible and adaptable along with the technology. Again, the goal is to build success, support the business with the side benefit of being able to do something new. Okay. So what are some additional considerations? We're almost here to our wrap-up. Is cloud native can increase complexity for some apps and environments that lack scale, at least initially. So you want to keep that as a balancing act. On the other hand, for environments that have large apps, that complexity that is brought to the table can be offset by the enablement. So are you looking for a reason to use a new technology, tool, technique, or trend? Or is there a business app or functionality need that can benefit? And can you do a cost ownership, a return on investment model? Are you into a mandate? We touched on this early on. Cloud native does not have to be an all or nothing approach. It can be phased in over time. You could have a portion of your application landscape using cloud native, while other parts are running maybe as a platform or software as a service or on traditional legacy apps communicating with each other. Where and how will the development be done? What runtime and platform and tools? And a couple different things is that it does require some discipline for the development and the architects That's part of that transformation, part of that culture shift. But also to watch out for that, avoid best-in-class tools that take over and bring in that scope creep. It's a balancing act. Does cloud require cloud native? No. Or does cloud native require cloud? Well, actually, it's the same. Clouds don't require cloud native. Cloud native doesn't require clouds, but they are better together. Do containers require cloud native? No. But cloud native and containers are better together. All right. Okay, the golden rule of cloud and cloud native is this. Whoever controls the management controls the gold. Let me repeat that. The golden rule of cloud native is whoever controls the platform management, development tools, and other tools or platforms controls the gold. For some, the above statement will be deja vu of the past. Well, for others, it may be new and revolutionary. For others, there may be that sense that cloud native eliminates the concern around entity, organization, or technology having control. Go in eyes wide open, set the expectations, look at what it is you're doing and what you're trying to accomplish, and I think you'll be able to move forward pretty good. Now, this session is being recorded. You'll be able to go back and review all these, so I am not going to go through this partial glossary of cloud native terms. You can look at these in the replay. And here's a few more. Some different glossaries, some different terms, some resources. There's some of my books that address technologies that we've talked about today along with others. All right. And some resources, where to learn more, a bunch of links here, a bunch of different things that you can look at, who's doing what. There's a really good eShop container reference app that you can get the code, download it, run it, modify it, and move more from just, hey, I spun up some containers to, hey, I actually got something running. I can go in there and do different things. So again, these are all part of what you can go through the download, so we're not going to drill through these. Let's wrap up, and then we're going to get into some Q&A. So what you can do next. Everything is not the same, so why treat it the same? Start simple. Build success. Build upon your successes. Know your business app requirements along with your workload profile. The best solution is the one that works for you and your organization. And keep the different layers, that different granularity and perspective. Where you can learn more, my site, storageioblog.com, my books, storageioblog.com/books. I'm on Twitter, storageio. My email is greg@storageio. And with that, we're going to bring Gladys back. Gladys, are you there for some Q&A?
Absolutely, and we do have a couple of questions, so I'm glad we're going to be able to squeeze a couple of these in before we move on. And thanks for that presentation, Greg. Also, those resources are going to be extremely helpful for the audience. Okay, so first question from Jason. He asks, what's the difference between cloud native and serverless?
Pardon for the interruption. Speaker has technical issues. Speaker will be back shortly.
Okay, thanks, Alan. Stay tuned, audience. We're going to get Greg back on in a second. As you know, this is part of the fun of having a live summit. In the meantime, while we're waiting for Greg to reconnect with us, check out those resources from Nutanix. Download them if you have any. Okay, great. Thanks, Alan.
Sorry.
Hey, Greg, can you hear us?
Sorry about that. Yep, sorry about that.
Yeah, no, not a problem. I'll kick it off with a question from Jason, who asks, what's the difference between cloud native and serverless?
Hey, that's a really good question. Is that serverless is a way of deploying all or parts of cloud native. In other words, a serverless is another way of a container of a resource. So in other words, if you've got a piece of code that's well-defined that you want to say, here, I'm just going to stuff it into a container and run in my own environment, and we're all going to be happy. Or you can just say, hey, you know what, this piece of code is very, very contained. I'm just going to run it on a serverless environment like on AWS Lambda or on Azure or somewhere else, where I'm not even going to worry about the containers. That is basically a container as a service, if you want to think of it that way.
Great. And here we have another question from Ramanath. I hope I'm pronouncing that right, who asks, tell us about low-code, no-code apps and their relevance in cloud native.
Yeah, so there's a couple things here we've got to be a little careful with, is that there's low code, there's low-level code, and then there's this notion of low code, no code. Well, okay, we'll take the latter first. There is no such thing as no code because, well, hardware needs code somewhere, someplace, in some instantiation, okay? The next truly revolutionary technology combination will be hardware that requires no software, software that requires no hardware without any marketing hyperbole in between. Now let's get back to reality. Low code is tools that, rather than getting in there and scripting and typing programmatic commands in your favorite language, whether it be Java, Python, C, whatever, you're actually working with an interface that it's more graphical, even more graphical than, say, something like using a Visual Studio, where you actually see different abstractions, different icons that you're putting things together. It's almost like putting together a PowerPoint deck where you're moving things around and connecting the different pieces together, so you're actually not even looking at code per se. But there is still a lot of code underneath the hood for what's going on.
Great. And that's, I find questions like that really useful because then they open the door for our expert, in this case you, Greg, to make these distinctions that aren't always obvious or are sometimes so obvious that they are not often thought of. So thanks for that question and that response.
Yeah, and what I forgot to mention there, then there is low-level code, which is just very, very low-level code, maybe a device driver or something, very, very low level. But again, it's all about abstractions. It's all about abstracting what's underneath.
Great. From Jen, she asks, are there certifications available for becoming cloud native?
I would say yes. Shop around. That's the thing with certifications is there's a whole industry built around just, do you want a certification and a certificate? The answer is yes. Just go to your particular favorite preferred provider of certificates or development languages or platforms, and you can get yourself certification, certificates, but more importantly, experience. That's what really comes down to, is getting that experience and do something.
Great. These are great questions, guys. Keep them coming in. From MJ, Greg, she asked, or he or she asked, do you have to be a Kubernetes expert to do cloud native?
I would say no. If Kubernetes is the only thing that you know, if that's your current focus or specialty, I would suggest, highly recommend that you move up the stack and learn more about the applications that are going to be running on it. And likewise, the other way around. If you're that app developer, learn more about what's underneath. Do you have to be able to install a Kubernetes cluster? There's a lot of prepackaged solutions that makes that easy. But you don't have to be that expert to be able to get into it. In fact, when you go to a lot of the different resource sites, they make it very, very easy. If you want to learn all of that, yeah, you can. But if your focus is, hey, I just want to get up and get some code, I want to get an application up and running, I don't want to sit here and build out my server farm and my clusters and my Kubernetes and all my containers, well, that's part of the idea with that cloud native, is to be able to abstract that.
Asgar asks, does cloud native have to run on a cloud?
Great question. Cloud native does not have to run on a cloud. Clouds do not have to have cloud native, but they are better together.
Great. I'm going to squeeze in one last question here from Greg. Oh, your namesake, Greg. Can existing applications be moved to cloud native?
Yes, absolutely. Existing apps can be moved. And this is, again, one of those balancing acts, which is that there's that temptation of, hey, let's do everything new. You know, forget about learning about it. It's a mess. We'll just throw something new together. Well, in that race to throw something new together, have you created a new problem for somebody else? Or are you going to take the time and say, okay, here's how we're going to go out doing it. We're going to take our existing application, maybe it's similar to what we showed on the screen, and we're going to decompose it. We're going to leave everything as is, and we're going to do it in phases. And the first phase is we're going to change identity management. Okay, we've rolled that out as a microservice that then still talks with the monolith, and the monolith talks to that. Okay, that went good. Now let's do another piece to it. Now let's do another piece. So you can do it rolling on the go, or you can also do it all in one approach. Which is better? That's going to depend on your environment, a lot of different factors, and different entities are going to say, no, you got to do it all in once, or yeah, you can do it all in phases. Just be aware, what are the pros, cons, the trade-offs for a given particular approach?
Great. And I think that's all the time we have for questions. Thanks so much, Greg. That was a great in-depth presentation and for answering all those questions. Everyone stay tuned. We're going to take a very quick break, and we'll be back at the top of the hour for a second session of the day called Cloud Native 102, the Cloud Native and DevOps Connection. So while you're waiting, do take a chance to check out those resources on your console provided by Nutanix, and we'll be right back.
Welcome back to our second session. David, please take it away.
Thanks, Alan. Okay, welcome back, everyone. I'm David Rammel, editor of Virtualization Cloud Review, thanking you for attending the summit and thanking our sponsor, Nutanix, for underwriting it and allowing us to bring you this great content. I'm moderating the second session of our summit called Cloud Native 102, the Cloud Native and DevOps Connection. Our speaker for this session is Carlos Rivas, a senior solutions architect. He has a background in software development, and he has worked as an independent cloud consultant, helping migrate California community colleges to the cloud. He is currently an AWS instructor, and you can find his work on LinkedIn Learning, Cloud Academy, and Udacity. Carlos, it's great to have you here. Please take it away.
Thank you so much for that wonderful introduction. How's everybody doing? As you can see, here is my slide. I decided to include my LinkedIn just in case you want to reach out. Because I'm an instructor, I'm always more than glad to help you out, answer your questions, and anything related to cloud or DevOps. Feel free to reach out. And with that, we're going to be teaching a few things here today. We're going to be talking about when it comes to cloud native, how do we combine that with DevOps and the various services that are available to you when trying to work your way around cloud native. Along the way, I'll be touching about serverless. I'm going to be talking about containers. And of course, I just don't like just giving you just random definitions and moving on. I'm going to be touching on some sample architectures that we can actually discuss and say, hey, this is how this actually looks like when you do the implementation. So not just concepts, right? So with that, let's go ahead and jump right in. All right, so what exactly are we talking about when we say cloud native? Cloud native is essentially using what's available to you in the cloud and not just bringing, what you already have in your data center or your traditional solutions or legacy, as I like to call those solutions. So I have a formal definition here. It's the cloud native. It's a solution that is entirely made from infrastructure and service components that are mostly managed by cloud vendors. I try to use the word mostly here because, there's nothing wrong if you have your traditional legacy app that you need to move, and perhaps you decide, well, I don't have the source code for this anymore, or it would be too expensive to modify. How do I take advantage of cloud native, if I have this old application? You still have options, such as containerizing your application, perhaps refactoring just one component and leaving most of the application as is. So that's why I use the word mostly in my definition. So keep that in mind. So it's not that, you have to be 100% serverless or otherwise you're not cloud native, things like that. So it's nothing to be stressed about. It's just, just a overall concept to keep you in line with what cloud native is. So how do we start? This is the most basic way to get started. This is Amazon Lightsail. It's essentially what I call the legacy of the cloud. Before we had the concept of cloud, we used to have virtual private servers. And that's exactly what Amazon Lightsail is. Essentially, it's an old school type of server where you connect to it and you can ask Amazon to have it deployed with any of these solutions that you see on screen, just ready-made. The most popular being WordPress, for example. That's why probably what they put it here first. So you would deploy a WordPress blog, for example, and it will be ready for you from the start. So you don't have to do anything. You just click a couple buttons, and it's good to go. So in this case, let's see. You also have Joomla, you have Node.js, you have Drupal. All those things are like ready-made, readily available for you. You have instances and containers and load balancers. All those things, all those components that you see on the screen here, these are, let me see, how can I put this? They are like cloud-native solutions, but you don't have to manage those. That's the whole point of a solution like Lightsail. So in this case, I need to know what a load balancer is. No, you don't really have to. In this case, what you would do is you would use Lightsail, and they will create the load balancers for you and manage those for you. Take, for example, databases. Databases is kind of like a really tough pill to swallow when it comes to AWS. So what you would do here is say, hey, Lightsail, I need a database for my WordPress, for example. So in that case, you would have Lightsail do the deployment for you, do the management. So all you need to do is essentially provide your data, and then you don't have to worry about it. Another example is CDN. You would be using CloudFront in AWS for CDNs. And again, you don't have to deploy it. You don't have to worry about anything. Lightsail will manage that for you. Let's switch gears a little bit here to Beanstalk. This would be like the second step above from Lightsail. This is still kind of a solution for developers. So essentially, if you have, let's say, a PHP app, again, like WordPress or some kind of blog, you would use Beanstalk for that deployment. One thing to mention is not only for something like PHP or something like that. If you have a containerized application, as I mentioned, you could have a legacy app that you can turn into a Docker container. Something like Beanstalk can do that for you as well. Something else is that it can manage, this is really the interesting part about Beanstalk. It can manage your entire infrastructure. Actually, let me see if I can find an example here. All right. For example, you have load balancers, and you have your backend EC2s. And you see the word environment here. It could be something like, test, prod, and staging, all those environments. And you don't even have to worry about that. You just say, hey, I need another environment, and it will create a new environment for you. So this is one of the greatest advantages of Cloud Native, is that it will do all the management for you. This is a more realistic looking example. So you have a Beanstalk application right here. And this application puts messages in the queue. Those messages can be, customer orders or web requests or anything that comes through your main application, and then it goes to a backend. And this backend, here's another great part about Cloud Native, is that you can have auto-scaling groups in this particular deployment, and you don't have to worry about, how do I manage this thing? I'm not familiar with auto-scaling groups. You don't really have to worry. You just ask Beanstalk, and it will do all the management for you. And this also include CloudWatch, because by the way, if you have auto-scaling groups, you're going to need something like CloudWatch, which provides alarms and scaling criteria so that your scaling groups know how to scale up or down based on specific events. Here's a little bit more elaborate version of the previous example that we saw. As I mentioned, we could have several environments, and you don't really have to do anything at all. You just say, hey, Beanstalk, I need a new environment, and it will essentially just deploy the same infrastructure for your application in a separate, isolated environment. Oh, and this one is showing actual container. I like this because Fargate itself, this is probably, we're going to be talking about this as well. Fargate is a service that essentially manages container infrastructure for you, so you don't really have to do anything there other than, of course, create your own containers. So now let's switch gears a little bit to Lambda. This is, we're stepping slowly up into the cloud native chain. And when you get to Lambda, essentially you're pretty much just providing the code. You don't really have to do any infrastructure management at all. With Beanstalk, we had to do some of it. With Lightsail, we didn't do much at all because it was provided to you with no flexibility. But with Lambda, the goal is that you only focus on your code. So this is more or less what a Lambda would look like. You have your Lambda, and your Lambda needs a trigger. And that trigger, for example, in this case, you're uploading images to an S3 bucket. And when an image comes in, you fire up your Lambda. Let's say that in the case of the Lambda, it's going to do some machine learning. For example, I actually created one application that looks just like this. And it was, I think I have it here. Let me see. Yeah, this is it. It used machine learning. So if you uploaded a picture of a receipt, it would actually scan the receipt and look for the total at the bottom of the receipt, and it will help you create an expense report automatically. And this was a very surprisingly small number of lines of code in Python just using Amazon machine learning services. So this is a great example of cloud native. In this case, serverless, of course. Now, one way to enhance the functionality of Lambdas is to combine them with step functions. Essentially, a step function is a workflow that helps developers use services to build distributed applications. So if you have your Lambdas all over the place, you have one trigger for this, one trigger for that. Instead of not being able to manage them, you have this tool which allows you to create a visual workflow, and you can see, okay, going from step 1 to step 2, step 3, and you can manage all your Lambda functions with this. This is more or less what it looks like, and I really like step functions because it allows for human steps. For example, this one here that says ship product, that could take 3 days, right? And you're not going to have your code waiting for an action to take place 3 days from now. So instead, you define that as a human step, for example. And the code will continue once a person logs in and says, okay, here's the tracking number. The box has been shipped to the customer. And then the step function workflow will continue. Another great thing about step functions is that they also provide retry logic. So let's say that you're passing data to a third-party vendor for processing. With step functions, you can say, okay, we got a failure notification. What do we do? You can specify, okay, I want you to retry 3 times, every 15 minutes. And you can do that without having to bake in that logic into your code, just using step functions to achieve that goal. Here's a little example that I took from the AWS blog. Essentially what it's doing here is managing attacks into your infrastructure. So you have this collection of services here that are protecting your infrastructure. You have Guard Duty, a Security Hub, and Event Bridge. And Event Bridge in this case is the trigger. You're going to have a step function that gets triggered by Event Bridge when one of these tools say, hey, we found this problem. We have this set of IPs that are trying to do a denial of service attack in your infrastructure. So that will trigger the step function machine in this case. And what it does is it's going to record the IP in a database, and this database is going to populate the network firewall. So in this case, oh, we're getting this particular subnet from this other country is attacking our infrastructure, and we want to be able to, accept valid and authentic traffic and be able to block the denial of service traffic. So you would just add that rule to your firewall using all this setup right here, and essentially you're automating your protection. This is a really great setup. I have to admit it's a little bit complex, so this is not something that you can expect to implement in an afternoon. But yeah, this can certainly help you protect your site from something like a denial of service attack, for example. Now, switching a little bit of gears to DevOps. DevOps is also something that's been growing quite a bit, especially in the cloud space, mainly because DevOps promotes automation over anything, over everything, and automation is also happens to be the #1 thing for cloud native. So AWS provides these set of tools here, code commit, code pipeline, code build, and these tools are precisely designed to trigger off automatic events, and also, you have traditional code check-ins. Oh, somebody just checked in code. Let me trigger a pipeline, and that pipeline is going to trigger a build. So all those things, you could do this with other more traditional tools, say, for example, Jenkins or Circle CI or GitLab. But yeah, just know that you have these options as cloud native as well. So if you want to stay within one provider, in this case, AWS, you can do that also. Here's what that looks like in a little bit of a more realistic scenario. You would have your code and code commit, and as soon as something happens to that code, something like somebody checking in code, that can trigger a code pipeline. And typically, code pipeline will be used to manage and trigger code build. I really like code build because it's essentially a tool, like a Docker container. It's very similar to what GitHub Actions is, which we're going to talk about. And you can assign a role to the code build, and it can go to your S3 buckets and get an artifact, like a web application that you design, and then turn that application into a container, or perhaps run a CloudFormation, create infrastructure as code. You have all kinds of options when it comes to code build. So let's pause for a second to talk about code pipeline, which is the main orchestrator for all this. Code pipeline essentially is going to be monitoring your source code. In this case, I mentioned code commit, but be aware that it can be GitHub, which to me is my favorite. I don't necessarily use code commit for everything. I try to use GitHub. This way I'm more not really locked in to Amazon in that particular sense, and I have more flexibility on GitHub for other things. But anyways, code pipeline can monitor those GitHub repositories or code commit repositories, and then of course trigger your builds. Now, when somebody hears about a build process, they assume that that's it, that's where it ends. Well, not really. You can also have a test process, or deployments to staging, deployments to production. The test, I really like the test, especially if you're a software developer, if you work in an environment where a lot of code is written. You might want to use tools that are running unit tests constantly before you proceed to do any deployments. Okay. So this way, if any of the tests fail, you can be sure that the code will not deploy to tests, or certainly not to production for sure, right? This is a more realistic scenario where you have code commit, and then that triggers a pipeline that is going to start a code build. And by the way, I didn't mention this tool, and I should have. This is Code Deploy. I really like Code Deploy as well. I haven't used it lately, but one of the main features that I like about that is that you can deploy pretty much anywhere, including to a non-AWS servers. And in this case, this is doing a Lambda deployment. And once that completes, it pulls data from SSM parameter store, which is another great tool to use to keep sensitive data away from your code. By the way, you never want to hard code password or store any sensitive data in your code. So you use something like AWS Secrets Manager, or in this case, parameter store. And of course, down at the bottom, you have your actual infrastructure where you have your load balancer. Actually, in this case, is a Beanstalk environment where you have your auto-scaling blue and green and an EFS store where everybody connects to. If you're not familiar with blue and green, that's essentially what happens when you're actually doing a deployment, where you would have an environment that is the current environment that is stable and running fine, and you have the new environment that is that's the one that you want to test with the new features and everything. And you only get rid of the current stable environment once you actually test it live, your proper environment. Then in that case, all these two becomes a single one, and operations resume normally. What this allows you to do is, because you have a load balancer, you can say, well, I'm going to go ahead and deploy. I'm only going to move, let's say, 10% of your users to the new environment, just in case the new features crash something, or something bad happens, something like that. And then you have the opportunity to roll back without touching your actual good working copy. So code build. Code build, essentially, the way that I use it the most is the number one thing here, which is Amazon ECR. I'm a big fan of containers, so when I'm using code build, I'm usually running some sort of Docker build process and deploying that artifact to ECR. However, it is just a generic environment where you can do anything, right? You can, pull secrets from Secret Manager, actually access resources within your VPC. Perhaps you have some licensing server or something that you need to access in your environment. You can do that as well. And in the end, if you're a more traditional developer, say you were running a build process, a Maven build process for a Java application, your result might be a jar file or a WAR file, and those are going to end up in S3. And once they end up in S3, then that's when they get picked up by something like Code Deploy, for example. But as I mentioned, the way I use this tool personally is to generate Docker container and store them in Amazon ECR. This is more or less what it looks like. My own build process. Yours, of course, was going to be different. You're going to have your code commit, which has your code. For me, it's usually Python. In this case, it's showing Python, R. It could be JavaScript. It could be pretty much anything, Node.js code, etc. And of course, in there, you're also going to have a Docker file. And if you're building containers, of course, you're going to have this file that says, hey, go to Docker Hub and get me the latest Tomcat or the latest Node.js or something like that. And once you have those base images, you can add your scripts. You can modify it to your needs, perhaps add any secrets or parameters or configuration files that are needed. And you can specify those in a build spec file that is also going to be in your repository. And of course, code build is going to be orchestrating everything I just said. And the result is going to be a Docker build and finally a Docker push with the result going to the Amazon ECR or Elastic Container Registry. Now, I mentioned briefly GitHub Actions, so I want to touch on this a little bit more. GitHub Actions is essentially the answer to code build, perhaps, but outside of AWS. So yeah, this is a tool that I use a lot. mainly at the request of other people. They say, hey, we rather not use code build. We think it's a little bit complex. We want to use something else. And then I usually offer something, okay, in that case, let's go ahead and use GitHub Actions. Let me explain what this is. GitHub Actions, you have YAML files, which is, I say YAML files, but it's these things right here that I mentioned. They're at least the build spec file is also a YAML file. So yeah, it's kind of a standard format in this case. And essentially, it's going to be a series of jobs. And these jobs are just made up of steps. And the steps are exactly what you think they are. So let's say, I'm building a Java application. One of the steps would be Maven build something, and those are going to run inside GitHub runners, which are essentially Docker containers managed by GitHub. So the process will run, and you will end up with some sort of artifact, just like you would in code build. And then you can pass this artifact, I want to store it in Amazon S3, or perhaps I want to build a Docker container and push it to ECR as well, which, by the way, I know GitHub is not really AWS, but if you pass the proper credentials to GitHub, you can just access any and all AWS resources just as normal, like no issues at all. This is more or less what it looks like, and this is actually pretty realistic to what I'm doing these days when not using code build. For example, you have the GitHub process will, check in, will check out your code. You will pull in any necessary credentials. We'll do a login to ECR. And once you have that, then it will look through your code for a Docker file and perhaps build an image. Once you build an image, you can add tags or anything that you need to do to your image. You usually use the latest tag and also perhaps an environment tag. I'm a big fan of environment tags so that hey, this build is going to production or it's going to test. And then from there, essentially, it's pretty much a deployment going to the actual infrastructure, in this case, Amazon ECS. I know some people prefer Kubernetes. Not a big fan of that platform at this time myself, but I use more traditional ECS. But again, they're both very cloud native in this case, so really not a problem with using one or the other. Now, I wanted to touch on this one, AWS Amplify. This is, again, very, very developer-centric. So if you're not a web developer yourself, you probably will not be using this tool. But yeah, this is something that, since we're talking about cloud native, not really 100% DevOps, I wanted to touch on this particular tool. Amplify helps you with both sides of the aisle, in this case, the back end, where it provides authentications and databases and all that, and connectivity to your application, as well as help you with the front end part, because you really don't want to confuse AWS Amplify, the back end, with AWS Amplify, the framework or the JavaScript framework, because it's two separate things, and they're both provided by Amazon. One will help you with the front end of your web application, and the other one is a CLI tool, also called AWS Amplify, which is going to help you with authentication, in this case, Amazon Cognito, with the REST API backend, in this case, AWS API Gateway. And then, of course, from there, you can wire up your Lambdas and your databases and any AWS monitoring and resources that your application may need along the way as well. This is a more traditional use for something like Amplify, and that's going to be a mobile application. Mobile applications are 100% going to be using Amazon Cognito for authentication, and they're very likely to use DynamoDB, because DynamoDB is a NoSQL JSON document type of database, which is really, really fast compared to something like RDS or something like that. S3 storage is going to be present, of course, in this type of setups. And of course, this is another reason to use Amplify, is because you have functionalities available to you to create a backend or an admin part of your application. And you can use Cognito to add like a little flag to your users in Cognito saying, hey, this user is an admin. So, allow this user into the backend so that they can manage databases, create users, enable, disable users, and so on. But yeah, Amplify, I wanted to make that clear that even though I said it's a web framework, but it can also help you if you're developing mobile, cloud-native mobile applications that use AWS. Now, as mentioned, Cognito is a really great tool when it comes to cloud-native validation for the purpose of authentication in this case. Not only authentication for your own apps, but you can also use it for authentication into AWS services. I think I have a diagram here for the architecture. Yes, we're going to get to this in a second. Let's talk about the features first. So Cognito can help you with federation. I really like that part, and we're going to talk about that here in a second. It can help you with user registration, which is when you're creating a web application, one of the most annoying parts is having to do the same user registration forms and process over and over again. With this tool, you already have that. Not only that, but you can also enforce multi-factor authentication. So let's say the new user signs in to your website, and you don't want to bother with people using fake emails and fake names. Well, you can actually enforce saying, okay, we're going to send a text to your mobile phone, and then go check give me that number, and then we're going to verify that you're an actual user with the phone, right? So this way you can filter out a lot of the bad traffic where you have people using other people's emails or fake email accounts to gain access to your application. So Cognito can certainly help you with that. And of course, let's not forget the most important thing in the first place, which is enforcing policies and access into your applications, as well as access to AWS resources. This is more or less the way I use it, and I actually did a course for LinkedIn years ago using these particular services. I'll tell you right now, this tool is not very easy or friendly to set up. But yeah, it's a really good feeling when you have your own application that has a series of buttons that says log in with your Amazon account, or log in with your Google, log in with your Facebook. And you just click that button, and it automatically creates a user into the application and goes to Facebook to authorize your access, and it comes back. Everything happens automatically behind the scenes once everything is properly wired up. And the proper name for this is login or user federation, when essentially you're connecting two identity providers, and then Cognito will go to that other provider to authenticate you and say, hey, yes, this is a real user, and you'll get that response back. And as I mentioned, something that I really like about this tool is that you can actually use it to access AWS services. So once you complete this federation and login process, you can associate an IAM role with your Cognito users so that people can actually say, oh, let me go ahead and access, these services. Of course, you will set your limitations. You don't want to give somebody full admin rights into AWS if they're just using one of your applications, because that could be disastrous. But, if they need to upload a file to S3 for whatever purpose of your application, you can do that from Cognito without having to worry about creating or managing your own policies and user profiles and permission sets. All right, let's see what we got here as key takeaways. Number one, always consider cost when it comes to native and versus an old-style migration. Let me explain this one. I know, cloud native is trendy, and you might want to go in that direction. That's fine. But sometimes you might just say, well, I'm just going to take this application, put it on an EC2 machine, and just move it to the cloud. Simple as that. And if that works for you, that's perfect. You don't need to follow any trends or like, oh no, this application needs to be serverless. I need to convert this into Lambdas or, something along those lines. You don't have to. Granted, of course, if you are cloud native, you're going to get a lot more benefits. As I mentioned, scalability. You don't have to worry about scalability if you're on serverless, for example, compared to migration. If you're just migrating from your on-prem data center to the cloud, then of course, if that server is ever going to scale, that's going to be on you to set up load balancers, to set up auto scaling groups. And when talking about legacy applications, some of them you might not even be allowed to scale those applications because the application might start conflicting with itself and deadlocking when writing to the database and things like that. So there's a lot of consideration when moving old applications to the cloud, but don't think that you are like, oh, you're missing out on everything if you're not cloud native. Now, control or simplicity. This is what I mentioned about using something like Lightsail in the beginning. It's very, very simple, but you have no control, right? You can install WordPress and AWS will manage content delivery, load balancer, scaling. They will do everything for you. But again, you have no control. So in that case, yes, you can install your own EC2 and install WordPress manually on that EC2. But then now you have full control, but now security is on you. And now setting up load balancer and scaling is on you. So if you have that knowledge, if you have access to those skills, then that's great. And that even allows you to take advantage of something like spot instances using EC2, which means it's probably going to be cheaper than Lightsail if you set it up correctly. So you have all those kinds of options, but it might be more expensive if you have to pay for the expertise of a cloud consultant to get that done, right? So if you have it, great. If not, stay to the simple side. Again, going back to that Lightsail example, but in your case, it might be something like Elastic Beanstalk, which is a way to manage everything I just said, but still maintaining some simplicity, but way more control than if you have something like Lightsail, for example. Now, another point is to watch out for vendor lock-in. So what happens with vendor lock-in is that, yes, Lambdas are great and all those services, step functions and everything, but then you realize, wait a minute, I think we'd be better off moving to that other cloud provider. Well, it might be too late, right? If you have thousands, perhaps hundreds of thousands of lines of code, and now you have to change cloud providers, it can get pretty tricky, right? So it's something to consider getting locked in to one of these vendors. So make sure that you're okay with the pricing and the services that you're getting, and it's all good. Then by all means, go ahead and do everything you need to do. I'll go back to my example here saying that I was using GitHub Actions instead of code build. That gives me some flexibility as to not be 100% locked into Amazon, right? So if I needed to change my cloud provider from Amazon to one of the other ones, I still have, my GitHub Actions are more or less going to be able to work the same, right? So it's not like, I'm totally locked into Amazon. There's no way out. Something for you to consider. Finally, it's compliance. For example, going back to this same thing that I just mentioned, GitHub Action, one of the disadvantages of using GitHub Action is that I'm doing something outside of my cloud environment and using, in this case, Microsoft, which would be the provider for GitHub. I'd rather not, for whatever reason, let's say that I can't move my data out of my AWS environment, I would say, well, I am forced for compliance reasons to stay within this VPC, within this cloud, and use only these tools because I need to comply with PCI, HIPAA, or some other requirement. In that case, it's something to consider. What tools can I use, and are those tools available to me within the environment? So in the case of Amazon, if you can't use something like GitHub, well, you can use Code Commit because Code Commit is within the Amazon environment, and it would have all these various compliance tools available to you. Say, this needs to be encrypted at rest and encrypted in transit, and you can control that, right? So, yeah, it's something, a point definitely to consider in this case. And David, that's what I have, David. So if we have questions, we can certainly start with those.
Yes, we do. Great job, Carlos. And we do have a lot of questions in the Q&A box. And I would like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session. So please send them on in now. And let's get to those questions. Here's one from Jason. Jason asks, how big, with big in quotation marks, how big does an application have to be before considering moving to a cloud?
Well, in that case, the answer is it really doesn't matter when it comes to sizing. If you're talking about sizing in terms of compute units, it can get pretty interesting very quickly when it comes to something like auto-scaling. So in that case, I would consider cost a significant factor there. If we're talking about size in terms of disk space, I would argue that probably the cloud is better than on-prem because you can manage costs a lot more, efficiently. So take something like S3 Glacier, for example, for cold storage. If you have a ton of data in the cloud that you don't use very much, you can move it to cold storage, and it would literally be pennies per gigabyte. So it would be super cheap. So, considering the word big in those terms, whether it's compute or disk space in this case, I would certainly not even think about it. I would just go cloud native as soon as possible.
Okay, great. Next question reads, is the microservice architecture a better fit for cloud native applications?
The answer to that is going to be a resounding yes. Let me explain why. Microservices are kind of designed, by definition, they're designed to be disconnected or decoupled from the rest of the components of the architecture. So, for example, if you have an authentication service, it doesn't need to be coupled with an inventory service or an orders service. They can talk to each other, certainly, but they don't need to be attached to one another. So, yeah, certainly something that the microservices architecture can handle. And, something like a step functions, AWS API gateway, or Lambdas, all three I just mentioned are cloud-native tools. And you can certainly combine them to create super nice microservices that are very, very reliable and scalable.
Okay, here's a question from Johnny. Rather cryptic question, in fact. It just says serverless or containerized, question mark. So
no,
I don't know if he's asking which one is better.
Yeah.
just speak on those two topics, Carlos.
Yeah, I can certainly speak to both of those, and it's a little bit difficult for me because I really like serverless, but my customers most of the time demand containerized applications. So we do what the end users actually need. In this case, containerized would be my go-to choice, not for a personal preference, but because that's what the customers demand the most. Because the reason about containers are being so popular is that you can take your old legacy application, stuff it into a container, and boom, now all of a sudden you can easily move it from one cloud to another, from one container platform to another, and everything it just flows so easily once you containerize an application. So containers all the way in this case.
Okay, I'm loving these audience questions, and I'd like to remind the audience to please send them in. We have plenty of time for some more, so send them on in now because Carlos lives and breathes this stuff. So this is a great opportunity for someone to get some expert one-on-one discourse with a bona fide cloud expert. And let's get to the next question. Try to stump Carlos. Is Elastic Beanstalk considered cloud native?
That's a great question. It goes back to what I just mentioned about microservices. Beanstalk is a way to simplify the cloud for developers. So if you are creating, web applications or containerized applications, and you say, well, I know my thing, I know how to do my thing, but I'm not a cloud infrastructure expert. What do I do? And that's when Elastic Beans comes in, providing load balancing, environment management, credentials, cloud monitoring, DevOps, all those tools. You don't have to set them up. You just use them as part of the Elastic Beanstalk setup. In fact, they have their own CLI or command line interface. So as you're developing, you can create your own configuration files and do your own deployment directly from Beanstalk. You don't even need to know AWS at all to actually use it. So, they try to mask the cloud portion or the infrastructure portion as much as possible. So yeah, it's a great tool. And it really works for those people that are not interested in becoming super cloud experts.
Okay, great. Next question reads, can I use the AWS code tools to create apps that aren't cloud-based? That's an interesting question. What do you have to say to that, Carlos?
It is indeed, and the answer is yes, because you can use, as I mentioned, you can use something like Code Pipeline to query and monitor a GitHub repository, which is outside of the cloud, and you can also use a tool like Code Deploy provided by AWS, and as long as you have the Code Deploy agent in your servers, it doesn't matter whether the servers are on premises or they're in another cloud provider. They could be anywhere. And, as long as that agent can talk to your code deploy setup, you can deploy to that server regardless of its location, whether it's a legacy one and an actual data center on-prem, or it could be even in another cloud provider.
Okay. Next question. Wouldn't using AWS Lambda lock my application to AWS forever?
Another great question. The answer to that is, I'm going to say it depends, because Lambdas, yes, I understand that Lambdas are an AWS thing. So if tomorrow morning you decide, well, I'm going to leave AWS, I'm going to Microsoft Cloud, the thing is that Lambdas, they don't really have that much proprietary stuff in there, unless, of course, you use a lot of AWS-specific APIs, and then now you're really locked in to AWS, and you can't go anywhere. But if you just have generic code doing business functionality, the part that is actually Lambda is not that much. So you could actually take that code and just put it in a Google Functions or in Azure as well, and it should work just fine, just with minimal changes.
Okay, looks like we only have a couple more questions, so I'd like to remind the audience we have time to answer some more, so please send them on in. Just go to that Q&A console, that box in your console, and send Carlos a question. And of those remaining questions, here's one that's asked, do we have to use AWS Lambda to be considered cloud native?
I'm going to say no to that, because there's so many options out there, and there's new services coming around all the time. And as long as you have something that is managed by your cloud provider, in this case AWS, you should be good to go with cloud native. The thing is, if you just move your services to something like EC2 and you move your databases mostly to RDS and things like that, then of course whatever management you were doing to these services on-prem, you're going to continue doing that management in the cloud. And that's kind of not the point here. You want to offload some of your work to the cloud provider, pay a little bit more, but let them handle your workload. So, you have Aurora, which is a serverless, one of the serverless database offerings in AWS. You have DynamoDB, which is another database that has all kinds of high-speed access and super high availability and scaling. And, you put your data into those services, and then from then on, you're basically hands-free. You don't have to manage these things on a day-to-day basis. That's the same case with Lambda. You put your code in there. You don't have to worry about, okay, what server do I need to run this code? It should be fine on its own, right? And that's kind of the point of going cloud native. You don't have to. You can step by step and get there. But yeah, just start somewhere that is at least somewhat cloud native. As I mentioned, Docker containers are a great starting point if you have a legacy app that you want to move to the cloud.
Okay, great. Looks like we only have one more question, so this is the audience's last chance to send in a question for Carlos, or we'll wrap up after this question. And this potentially last question reads, is it cost-effective to convert a legacy application to cloud native?
Let me think about this one. To convert it, well, it really depends on sizing and capacity to get this job done. Sometimes it's just better to just move it over. So as I was mentioning, you can just take something and just stuff it in a container, or perhaps just put it in an EC2 and run it in the cloud and call it a day. Then you're done. But that's not going to get you any closer to cloud native. Now you're just managing a server in a different data center that is not yours. Now it belongs to AWS. So, but yeah, it's a starting point, and then from there you can say, well, I'm going to take portions of the application and disable it, and I'm going to rewrite that in a Lambda somehow, and then step by step evolve your application into a full-blown cloud service that you don't have to manage any infrastructure at all to get it to run. So, yeah, cost is a factor for sure, and certainly time, especially if you need to hire consultants and things like that to get the job done. But yeah, it is certainly possible, and just like I said, just take it step by step all the way to full cloud native.
Okay, well, looks like that's all the questions we have time for. So thanks again, Carlos, for a great presentation and answering all of those questions.
Thank you. My pleasure.